This is the moment two Iranian anti-ship missiles lock onto the USS Abraham Lincoln, and a US destroyer has only minutes to react. Launched from deep within Iran, two Abu Mahdi cruise missiles lifted off from their mobile launchers almost simultaneously. Immediately after launch, they split, taking two completely different attack vectors. One climbed high for a top-down approach, while the other dropped low, attempting to fly beneath the American radar coverage. And what made this threat even more dangerous was that these missiles didn't require constant guidance from the ground. They were fire and forget. Using an inertial navigation system paired with satellite positioning and an active radar seeker for the terminal phase, their objective was clear: the aircraft carrier USS Abraham Lincoln. But before they could reach their primary target, another ship detected the threat. It was the destroyer USS Gravely. Now, the question was, is there enough time to react? Before we continue, drop your thoughts in the comments below. Type 9 if you stand with the United States, type 1 if you back Iran. And if you're a proponent of world peace, type 5. Now, get ready for combat. At 3:43 a.m. on the 8th of May 2026, from a mobile missile unit deep inside Iranian territory, two Abu Mahdi anti-ship cruise missiles were launched into the night sky. Unlike previous short-range weapons, the Abu Mahdi is designed for long-range naval strike missions. The missile has a range of approximately 1,000 kilometers, a subsonic speed of Mach 0.8 to 0.9, and is optimized for sea-skimming flight to reduce its radar cross-section. And now, they were screaming toward the Abraham Lincoln carrier strike group. Immediately after launch, the first missile banked hard to the northeast and climbed to an altitude of around 15,000 feet. This tactic would allow it to approach from high above before diving down in its final attack run. Meanwhile, the second missile took a completely different path. It employed a tactic known as sea skimming, hugging the ocean's surface. The missile maintained an altitude of just 10 to 15 feet above the water, streaking forward at nearly 560 miles per hour. At such a low altitude, a warship's radar can only detect the target once it pops over the radar horizon. This meant the Abraham Lincoln carrier strike group would have only a few dozen minutes, perhaps even less, to detect and react. And while that might sound like enough time, both missiles were engineered to penetrate modern naval defenses. The first to detect the inbound threat wasn't the Abraham Lincoln. It was one of her escorts, operating about 20 miles off the formation's port side, the USS Gravely. While on watch, the quiet, monotonous atmosphere of a mid-watch on the Gravely was shattered. On the ship's radar console, two unknown contacts appeared, moving fast and on a direct course for the carrier group. Almost instantly, the ship and her crew began to execute the U.S. Navy's standard combat procedure to generate a firing solution and protect the USS Abraham Lincoln. That procedure is called FTTTEA. FTTTEA stands for Find, Fix, Track, Target, Engage, and Assess. It is the core foundation of the U.S. Navy's air and missile defense strategy, and it all begins with the ANSPY-1 radar. With 3 radar arrays on a destroyer and 4 on a cruiser, the SPY-1 system provides 360-degree coverage around the ship, from the 0-degree horizon up to the 90-degree zenith directly overhead. It is the backbone of the first step, Find, in the process of killing threats like the 2 inbound Abu Mahdi missiles. During the Find phase, the SPY-1 radar can scan out to at least 200 nautical miles, detecting any object that enters the airspace around the strike group. At this stage, the Aegis Combat System, which integrates the SPY-1 with all the ship's weapons and sensors, is simply identifying what's out there. It could be a cruise missile, an aircraft, a helicopter, a drone, a weather cloud, or even a flock of birds. The radar just needs to get a return signal off any object. The Abu Mahdi missile tries to defeat this stage in several ways. By sea skimming at just a few feet, it can hide behind the radar horizon, meaning warships can only detect it when it's very close. Furthermore, with a range of up to 1,000 kilometers, the missile can approach from completely unexpected angles, from behind the U.S. formation at a low angle near the sea, or from high altitude before diving on the target. Despite being about 20 to 23 feet long, the missile's body is designed to have a small radar cross-section, making its radar return much smaller than its actual size. This small RCS can challenge many conventional radar systems, but not the SPY-1, as it's impossible to be completely invisible to a radar that can detect an object the size of a golf ball from over 100 miles away. The Iranian Abu Mahdi missiles must rely on exploiting the next phase of the U.S. defense cycle. Fix. As soon as the AN/SPY-1 detected the two anomalous contacts, the system began pulsing out radio waves in the 2.5 to 3.7 GHz frequency band. These radar pulses bounce off the targets, allowing the system to calculate the precise coordinates, heading, speed, and altitude of each missile. Meanwhile, the other side wasn't standing still. The two Iranian Abu Mahdi cruise missiles began making slight, weaving course corrections, complicating the prediction of their flight path. They use an inertial guidance system combined with satellite navigation signals, allowing them to fly accurately even if GPS signals are jammed. In some scenarios, Iranian missile controllers can even update the target coordinates mid-flight using reconnaissance data from coastal radars, scout aircraft, or satellites. This is crucial when attacking mobile targets like warships, whose positions constantly change. But despite these sophisticated tactics, the SPY-1 radar maintained a firm lock on both missiles. Instantly, the system shifted to the next phase, track. During the track phase, the SPY-1 radar continuously illuminates the targets with an extremely high-frequency pulse rate, gathering more and more detailed data on their flight path, acceleration, and movement. All this data is then fed into the Aegis system's supercomputers, known as the Command and Decision, or C&D, system. This is the brain of the entire shipboard combat system. The C&D computers can perform millions of calculations per second, simultaneously tracking and analyzing over 100 different targets. The two Abu Mahdi missiles were flying at a subsonic speed of around Mach 0.8 to 0.9, but the system is designed to handle targets moving many times faster than sound. For Aegis, tracking two such targets is almost trivial. Within seconds, the computers had calculated a fire control solution for both missiles. But before any interceptors could be launched, one more critical step remained: target, also known as weapon selection. In this phase, the ship's tactical action officer, or TIO, has to make a split-second decision. It's like a high-stakes version of speed dating, where the goal is to find the perfect match between weapon and target. Theoretically, the TAO could order the launch of a top-of-the-line SM-6 missile to take out the Iranian threats, but that would be like using a $4 million missile to shoot down a much lower-value target, not a cost-effective choice. So, with the help of the Aegis system, the TAO has mere seconds to select the most appropriate weapon for the job. In this case, he chose the SM-2 air defense missile. The SM-2 is the workhorse of U.S. Navy air defense and is commonly used against threats like anti-ship cruise missiles. That's because each missile type in the Navy's arsenal is designed for very different missions. The SM-6 is for high-end, very long-range targets. The SM-3 is a dedicated ballistic missile interceptor for threats outside the atmosphere. The ESSM is optimized for close-in, sea-skimming targets. Anti-submarine rockets are for subs, Tomahawks are for land attack, and the SM-2 sits right in the middle of all those roles. A versatile, reliable, and highly effective air defense weapon. But even after selecting the SM-2, there are still different versions. The Block 3, 3IA, 3IB, and 3IC variants look similar on the outside, but internally, they differ in their radar seekers, guidance systems, and control software. Depending on the target, each version is suited for different threat profiles. Some are optimized for high-diving targets, while others are specifically designed to kill sea skimmers. In a few tense seconds, the TAO confirmed his weapon selection. Then, he flipped the fire-enable switch to green. Seconds later, the ship's deck vibrated slightly. From the Mk-41 vertical launch system, SM-2 missiles roared into the night sky. They accelerated almost instantly, reaching speeds of around Mach 3.5, over 3 times the speed of sound. The life-or-death race had begun. 2 American interceptors were now screaming toward 2 Iranian anti-ship missiles. The distance between them was closing every second. And this is when the next phase began. Engage. During this phase, the AN/SPY-1 radar establishes an uplink with the interceptors in flight. Dozens of times per second, the radar queries the SM-2S for their current position, and the missiles send a response back to the ship's control system. Based on that data, the SPY-1 radar sends minute course correction commands, helping the missiles fine-tune their trajectory for a more precise approach. As the SM-2S closed in on the 2 Iranian Abu Mahdi missiles, they entered the terminal phase of their flight. At this point, another radar system plays a crucial role. The AN/SPG-62. These square radar arrays, about 7.5 by 7.5 feet, are the core component of the ship's Mk-99 fire control system. As mentioned, the SPY-1 radar guides the missile for most of its journey. But in the final 60 seconds, the AN/SPG-62 illuminators kick in. They paint each target with an incredibly powerful, focused radar beam, about 10 kilowatts of energy. These radar waves, operating in the 8 to 12 GHz band, are something the SM-2's semi-active radar seeker is designed to recognize. Once the target is painted by the illuminator, the SM-2's seeker automatically locks onto the reflected signal. It's like a moth to a flame. It can't resist that signal. When the SM-2 senses it's close enough to the radar reflection, it prepares to detonate its warhead. The SM-2's warhead contains thousands of preformed metal fragments. When it explodes, it unleashes about 6,000 steel projectiles in all directions at nearly 4,500 feet per second. And that's when the final phase plays out. The first shots came from the destroyer USS Gravely, one of the escorts protecting the USS Abraham Lincoln. At precisely 3:45 a.m., the hatches of the Mk-41 VLS flew open. 2 SM-2 missiles blasted out, banking hard toward the inbound threats at Mach 3.5. These interceptors can cover 5 miles in about 7 seconds. The first missile soared high, its nose pointed at the high-altitude Abu Mahdi missile, which was expected to dive in its terminal phase. Thanks to the real-time data link, the SM-2 made tiny course corrections as it approached the target at over 16,000 feet. The system determined the intercept point was optimal. The proximity fuse triggered when the missile was about 50 feet from its target. A flash lit up the darkness. The fragmentation warhead exploded in midair, unleashing thousands of metal shards in a focused cone. The first Abu Mahdi's fuselage was shredded instantly. It broke apart into a shower of burning debris that rained down into the ocean. Meanwhile, the second SM-2 faced a tougher challenge. The second Abu Mahdi was hugging the sea, just feet above the water, trying to hide in the radar clutter of the horizon. But the SPY-1 radar maintained a solid track. As the SM-2 closed in, the Iranian missile suddenly jinked, banking hard to evade the intercept. But it was too late. The American interceptor dropped low, cutting across the target's flight path. In a split second, its warhead detonated directly in front of the Abu Mahdi's nose. Thousands of metal fragments traveling at hypersonic speeds tore through the missile's airframe and control systems. What was left of it tumbled end over end before crashing into the sea and disappearing beneath the waves. But the mission wasn't over. After the SM-2S detonated, the AN/SPY-1 radar continued to scan the entire area. The system checked every piece of debris, analyzing its trajectory, speed, and radar signature. If any object still behaved like a missile, aircraft, or airborne threat, the Aegis system and the entire crew would still treat it as hostile. That means the ship would continue to launch missiles if necessary. Only when the radar screens were completely clear of any targets moving on a threatening trajectory could the USS Abraham Lincoln carrier strike group be certain the threat was truly eliminated. But even as the radar screens appeared clear, the sailors in the carrier strike group had no way of knowing that the real attack hadn't even finished. In the brief moment of quiet after the 2 Iranian missiles were intercepted, many on the escort ships might have thought the danger had passed. The reality was completely different. No one in the U.S. formation knew that Iran was preparing a new wave of attack, using a tactic completely different from what had just occurred. This time, they weren't relying on old Cold War-era anti-ship missiles. Instead, they were deploying a new generation of cruise missiles. What some military experts call the poor man's cruise missile, far cheaper than modern systems, but still dangerous enough to inflict serious damage. That weapon was Iran's Abu Mahdi anti-ship missile. To the untrained eye, it might look like a simple cruise missile, but its design is more sophisticated than it appears. The Abu Mahdi is a long-range anti-ship cruise missile designed to attack naval targets like warships or aircraft carriers, developed based on Iran's cruise missile technology, with many domestically produced components. It is essentially a long-range strike weapon carrying a heavy warhead optimized for naval warfare. Each Abu Mahdi can carry a warhead of around 330 to 440 pounds of high explosive. On approach, the missile can either sea-skim just feet above the water to evade radar or dive on its target from a high angle. When the warhead detonates, the blast energy and high-velocity fragments can cause catastrophic damage to any ship in the impact zone. Unlike many older weapons, Iran's Abu Mahdi missiles don't need continuous guidance. They are pre-programmed with an inertial navigation system combined with satellite positioning, allowing the missile to fly precisely to predetermined coordinates. In some cases, target data can even be updated mid-flight via reconnaissance systems like coastal radar or other surveillance platforms. This means multiple missiles can be launched simultaneously without needing direct, continuous communication with the launcher. They simply fly their programmed routes, find their targets, and attack. The Abu Mahdi has a range of up to 1,000 kilometers. With a cruise speed of Mach 0.8 to 0.9, or nearly 560 miles per hour, they can approach a U.S. naval force from a great distance. In the terminal phase, many of these cruise missiles will drop to just a few feet above the water, using sea-skimming tactics to reduce the chance of early detection. The missile isn't exceptionally fast compared to modern hypersonic weapons, nor is it completely stealthy. But that's not the point. The true power of this tactic lies in numbers. And that's exactly what the USS Abraham Lincoln carrier strike group was completely unaware of at that moment. At a secret location deep inside Iran, missile units had pre-positioned multiple mobile launchers. In just a few minutes, a massive barrage of Abu Mahdi missiles was launched into the sky. And now, they are all screaming toward the USS Abraham Lincoln carrier strike group,